Hi guys, in this video we're going to go through velocity time graphs. So first things first, we need to recall that if we have displacement, when we differentiate that, we get velocity, and if we differentiate a second time, we get acceleration. And then if we have acceleration and we integrate, we get velocity. If we integrate again, we get displacement. That's very, very important. So a velocity time graph just has time on the x-axis and velocity on the y-axis. So this is one of the most basic forms of a velocity time graph. On this graph here we can see that there's a person traveling at a constant speed of 20 meters per second, and they're traveling at that speed for 30 seconds. Right, this is most important. So the area under the curve of a velocity time graph represents an object's displacement at that time. For example, so integration gives the area under the curve. And when velocity is integrated, it gives displacement, right? So it makes sense that the area under the curve of a velocity time graph is going to give us the displacement. So in this example, the area under the curve would just be 20 times 30 because it's a rectangle. And it also makes sense when comparing to just our average speed equals distance over time formula. That formula can be rearranged to distance equals speed times time. And then 20 times 30 would be 600. And that 600 value, the units would be meters because it represents the displacement that has occurred after 30 seconds for someone traveling at a constant speed of 20 meters per second. We can also verify this displacement using integration techniques. So in this case, the velocity function is just 20 because it's a constant. So to find the displacement between 0 and 30, it makes sense. I've got to integrate this velocity function between 0 and 30. So when I integrate that, I get 20t. We're going to have 30 and 0 as our intervals. Doing a bit of maths, which is assumed knowledge, we get 600 meters as we would expect. So just to recap, right, really, really important. It's the whole kind of point of all of this is the area under the curve of a velocity time graph represents the object's displacement. So if we were to find the integral of a velocity time graph, what we're finding the displacement of an object. Now the second thing that is most important is the gradient or the slope of a velocity time graph represents the acceleration of the object. For example, when velocity is differentiated, it gives us an acceleration function. So this graph has an acceleration of 0.5. So we can see that Vt is equal to half t, and since Vt is just the integral of acceleration, if we integrate a half, right, we're going to get half t plus c. We could just assume that we're starting from rest for this situation, so that means that when the time is equal to 0, velocity is equal to 0. And then therefore that gives us our velocity function. Notice this is a linear function, hence y equals mx plus c. So it makes sense that the gradient of this velocity time graph represents the acceleration of the object. So just to summarize this video, 1, the area under the curve, or the integral, of a velocity function gives us displacement, and the gradient or the slope, which is the derivative of a velocity function, gives acceleration.